Hello student, I am Mrs. Shweta Shailendra Pandare, Assistant Teacher, Vidyapeeth High School, Kolhapur. Chapter 4, Altitudes and Medians of a Triangle. Let us see second part, Median. Let's learn about median. Observe this figure in triangle HFC. There is a segment drawn from this vertex F toward this the opposite side, that is FD. Okay, the segment joining the vertex and midpoint of opposite side is called median of the triangle. So this FD is drawn from this vertex toward the opposite side, that is HC, which is the midpoint. This is D is the midpoint. That midpoint divide this the segment that HC in two equal parts. So this is called the median of triangle. As like this, we can draw the second median from this the vertex, that is H, on the opposite side, that is the FC. Let us see here, from this H on the opposite side, that is FG, this median also make that the two same parts of this segment FC. Third, we can draw from this point or this vertex, that is C, on the opposite side, that is FH. Let us see here, from this opposite side on the HF, this is the median. So again see the definition of median, that the segment joining vertex, this vertex, and midpoint of opposite side is called median of triangle. So in the triangle HCF, seg FD is median on the base, that is CH. Let's see construction of medians. This is the acute angle triangle, that is triangle ABC. That is, draw triangle ABC, find the midpoint P of the side AB and draw CP. Hence here is the side AB and the point, that is midpoint of this AB is P, and here midpoint is found by the side bisector, or this side is bisect and then got here the midpoint and join this midpoint to the vertex, that is the C. Hence C is the vertex and opposite side is the AB, and hence here join this the P point with the vertex C and we got the segment, that is CP. As like this, these two sides also bisect, that is side BC, that is midpoint Q, and that join to the vertex, that is A vertex, and here is the median, that is got AQ. Then third median, that is the point or midpoint R, that is the midpoint of side AC, and the opposite to that vertex is that is B, and BR is the segment drawn here, and that is the median from the point B. So seg, that is PC, then seg QA and seg BR are the medians of this triangle ABC. And here is the midpoint or the point of concurrence, that is called centroid, and that denoted by G. So as like this we can construct the median. Here is also a acute angle triangle, and that also having these three medians. So let us see how to construct medians by the examples in the practice set. Practice set 4.1. Question number 3. Draw an obtuse angle triangle STV. Draw its medians and show the centroid. Let us draw first the obtuse angle triangle. Here no measurements are given us. Hence we are drawing the first segment, that is TV. Then this is obtuse angle triangle, hence greater than 90 degree. So you can take measurements here. (110°). This is the obtuse angle triangle, that is STV. We are drawing the medians of this triangle, hence you can use for median for obtaining the midpoints of all the sides of this triangle. First side, that is side TV. So for finding the midpoint we can take distance as like this, that is more than the half cm from this line, and make arcs or curves here. Then put on the V point. Again we can mark here. Then join these 2 points. Then bisect the line ST. Again we can take the distance more than half of the ST and make arcs to the both side. Put on the point S. Then join these 2 points. Here we are get the midpoint of side ST. Then third line or third segment, that is SV. Hence bisect the segment SV. Take more than half distance of this segment SV and mark the curves or arc from these 2 points. Then put the metal point on this S point and again mark the curve. Then you join these 2 points here and here. This is the midpoint of SV. So this is midpoint, that is, we name that P. This is the midpoint, that is Q, and that the side ST having, this is the midpoint, that is R. So we got here the midpoints of the 3 sides of obtuse angle triangle. Then let us again see what is the definition of median. The segment join from the vertex and the midpoint of opposite side is called median. Hence we are joining the vertex point and the midpoint of the opposite side. Let us see first vertex point, that is T, and opposite side is SV. Hence we are joining. Here I use the red pen. For your understanding, you use the pencil. This is first median. Then second point, that is point V. Opposite side, that is TS, and the midpoint of TS is R. Hence we are joining these 2 points. Then next, that is the point S or vertex X and opposite side, that is TV, and the midpoint of TV is Q. Hence join these. Here we get the center point, that is called the centroid, the point of concurrence. The 3 medians are concurrence here, and that point is called centroid, and it is denoted by G, capital G, and its location is interior to the triangle. Hence this is the obtuse angle triangle. These are the 3 medians of this triangle, and this is the centroid or the that is denoted by G. Question number 5. Draw the right angled triangle XYZ. Draw its medians and show their point of concurrence by G. Let's draw the right angle triangle. First segment, that is YZ. Then for drawing the right angle triangle, use the set square here. Use the set square perfectly. and draw, that is the 90-degree join these 2 points. This is x, hence this is right angle triangle x, y, z. Again we bisect the 3 sides. First side, that is side yz, put the metal point on y and take the distance more than half. Here make curves 2 sides here. Then again you put the metal point on z and make the curves. Then join these 2 points. Extend the line. Here we get the midpoint of yz, that is point A. Then next line, next, that is the segment xz, take the distance more than half and make arc to the both side. Again you put the metal point on this x and cross the curve. Then join these 2 points. This is the midpoint of that segment xz or side xz. This is the B point. Then again bisect the segment xy, take more than half distance in your compass and then make curves to the both side of the segment. Then put on the X here and cross curves here. Join these 2 points. Join these 2 points. Here we get the midpoint of the xy, that is point C. Okay, then the vertex point and the midpoint of the opposite side we can join here. Hence first vertex, that is the y, and the midpoint of the xz. Here is the B is the midpoint. Join these. Here I use the red pen for your understanding. You use the pencil. Then X, that is the vertex, opposite side YZ, and midpoint of YZ is A. So join these. Then vertex Z and opposite side yx or xy and midpoint, that is the C. Here we are getting the point of concurrence and that point name G. So this is the centroid or the point of concurrence of right angle triangle X, Y, Z. By all the construction of the medians, that is acute angle triangle, here are the three medians, then right angle triangle also having three medians, and obtuse angle triangle having three medians. By constructing, now I know the median of a triangle are concurrent. Their point of concurrence is called the centroid. Here the centroid of acute angle triangle, here the centroid of right angle triangle, here the centroid of the obtuse angle triangle, and this is denoted by G. For all type of triangles, the location of G is in the interior of the triangles. So let us see, all the centroids are interior in the triangles. The centroid divide each medians in the ratio 2:1. These we are seen in the next point.